would like to welcome you to the second press conference of EGU2009, and immediately I will give over the microphone to Albert Gerdes, who is the media manager, public relations manager of IODP.
This
well,
is
just
like everything.
tell us who you are.
Thank you.
Thank you very much.
Okay, like
You'll have to excuse me, I have to go. So
yes.
The show is all yours.
Well, it's okay, so I think you can understand. Okay, wegen Übertragung. Okay, thank you. Okay, Dick and I, we know each other since 1992, so I was happy to take over. We were on an expedition in the Antarctic, and but this was not about ocean drilling, that expedition, but now, today in this media conference, which I really warmly welcome you all, is about ocean drilling, scientific ocean drilling, and I'm very happy to introduce to you two eminent scientists of the Integrated Ocean Drilling Program scientific community. On the one hand, Catherine Mevel. She is at the Institut de Physique du Globe in Paris, and she is director of the European branch, I would say, the so-called ECORD Management Agency. ECORD is the European consortium within IODP. On the other hand, there is Rüdiger Stein, a colleague from the Alfred Wegener Institute in Bremerhaven in Germany. And Rüdiger is here because he's also convener, and I have to look at my thing here, at the convener of the EGU interdivision session Beyond 2013, the future of European scientific drilling, which will take place on Thursday. And the future is the key word here, because we, in this media conference, will talk about the future of ocean drilling and the future of IODP. So I'm happy to hand over to Catherine. I think you need to use the microphone because you stream it. The structure is so that we have a few slides to just give you a brief introduction, and then we quickly start the question and answer thing.
How do you open it? How do you open from this?
Yes.
Okay, so I'm pleased to be here and talk about this program. I was first involved in ocean drilling in 1977, so it was a long time ago. So IODP is the Integrated Ocean Drilling Program, and it currently has 24 member countries. And USA and Japan are what we call the lead agency because they are the highest contributor financially. And in IODP, we have formed a consortium called ECORD, European Consortium for Ocean Research Drilling, which now has 16 European countries and Canada. And ECORD is considered as a contributing member to IODP, and I will explain why. IODP is the first international program in earth sciences, and the budget in 2009 is about $200 million. So you see, it's a huge program. IODP addresses three major themes, and our global aim is to understand how the system Earth functions, and you have here a little cartoon showing that everything is linked. We have three major themes. The first one is the deep biosphere and subsea floor ocean, and you may be aware that we have discovered by drilling that the biosphere extends down to 1,500 kilometers. You have living organisms in the sediments at that depth. What did I say? Oh no, I'm sorry. I was a little too greedy. 1,500 meters. The second theme is environmental change processes and effects, and Rudy is going to talk more about that. And the third theme is solid earth cycles and geodynamics. And I will tell a little more about what we are doing on geohazards and earthquakes, understanding of earthquakes processes. To address these themes, we are operating three platforms. the Japanese have built a brand new ship called the Chikyu, which is equipped with a riser, which is a system which allows to circulate mud in the borehole, so it allows to drill in unstable formation and probably at deeper depths, hopefully to 6,000 to 7,000 kilometers this time. The American operate the JOIDES Resolution, which is a non-riser vessel, and the JOIDES Resolution just went through a major refit. It's brand new now, it's always the same ship, but it's totally different, and it started operating again in March. And ECORD, and this is why we are a contributing member, we are operating what we call mission-specific platforms, which are platforms that we lease on a case-by-case basis to address specific scientific questions in areas which are not accessible to the other ships. And these areas are shallow waters and ice-covered. And again, Rüdiger will tell more about ice-covered areas. So far, IODP has accomplished all the expedition in orange, and what is in blue is currently going on or will be operated in 2009. I won't expand. If you want more information, you just ask me. I just want to emphasize a little the generation of earthquakes. Because we are now able to operate a riser vessel, we have developed a major plan to understand how seismogenic zone functions. And the area selected is the Nankai Trough, which is off Japan. You see the map of Japan here. And a major experiment involving a series of holes is being conducted right now. The first samples we have recovered for the fault zone look like that, so it's just to show you what they look like. They are completely crushed. And the aim to better understand the functioning of the fault zone is to develop an observatory to monitor the fluid pressure, all the fluid movement, the seismic activity and the deformation. And this is to have a long-term idea of how the fault zone functions, and maybe to be able to predict earthquakes in the future. What is really important is in IODP is that what we do is all the cores and data which are collected are available for the scientific community. This is what we call the IODP legacy. All the data are stored in databases accessible through the web, and the rocks and sediment are stored in 3 core repositories. One is in Japan, one is in the US, and the last one is in Germany, and you have here a picture of one of these core repositories. So this is really important because it's a legacy for the future, and you can come back to the samples and the data and address new questions if you have new ideas. So I will stop here and I will pass the ground to Rudi.
So I would like to add a few slides, and then I think we can start with answering your question. So how
Slideshow.
So I would like to start with.
Rüdiger, can you sit down with the microphone because of the
Okay, I'm sorry. So, you know, I changed this. So just a slide showing that the scientific drilling program already started in 1966, and with the DSDP, then the ODP, and now we have the IODP, Katrin mentioned. And I added here on this slide my own experience. So I was in a lucky situation already to be on board the old Glomar Challenger in 1982, of course. And so I'm a sedimentologist and paleoceanographer, and I would concentrate a little bit on the environmental change processes and effects, one of the major themes of the IODP program. And here I would to highlight of one major point within the IODP system is that to study the poorly known Arctic Ocean, that means the high north and latitudes. It belongs to the emerging fields, new topics, and really unknown areas. If you look at this map, all the yellow, green, and red dots are locations where sites were drilled, the sediments were recovered within IODP, DSDP, and ODP. And in the middle of the figure, you see the Arctic Ocean, and there's just one spot. That means we drilled one site, and a lot of very new and very interesting results came out of this first expedition. And so for the first time we know that the Arctic was really wet and hot, so the water temperature was 24 degrees Celsius. You know, today it's minus 1.5 or so. And this was totally unknown, and according to the modelers, and so it should have been 10 or so. So it was really a surprise. And then another highlight was in the left-hand side, you see this fresh Arctic Ocean. So there was a period where the Arctic Ocean was covered by fresh water. And another highlight, since about 46 million years before present, the Arctic, the North Pole area was covered by ice. And this was really not known. If you go into a textbook, then it's written there 15 million years before present, the ice started to be built. And so it was really a big surprise that that in the Eocene, 46 million years ago, we already had ice. But if you look at this nice figure, I will not go into detail. It's a global climate curve over the last 70 million years and 50 million years. You see it was quite warm, and then the global climate started to cool, and we got first ice, and so on and so on. And what you see there in gray on this map, that's the interval from 45 to 16 or 40 million years before present. It's not recovered in this first drill hole, so we do not have any idea about the climate and the change in the Arctic from this wave from greenhouse to icehouse. So it's virtually unknown, and this will be something for the future. Another important aspect for the high latitudes is what is known that the area around the Arctic Ocean is covered by permafrost. That means frozen ground throughout the year, and there are a lot of gas hydrates sitting there. The orange fields are hydrates. And you know that maybe from the newspapers or so, that people think that this gas hydrates might be destroyed due to the warming. Then you get methane into the atmosphere. You may get slope stabilities, what's written there on the left-hand side, and sediment instability. Constructions might be destroyed, and so on and so on. And it's also important as an energy resource. So there are important questions to be studied, and for the near future, for the coming, not near future, maybe for the next 1-2 decades. And for this, of course, we need partly new technologies. There are different types of technologies. Cheaper ones. On the left-hand side, you see a drilling device where you can get short sediment cores of 10 to 50 meters or so. And then the dream of people working in the Arctic are this new drill ship which can go into the ice-covered region. So this is in discussion, and hopefully this will become reality, and with this really a new era of drilling and Arctic research will start. And to talk about this, we will have this session on Thursday, Albert already mentioned, and directly behind this meeting on Friday and Saturday, we will have a workshop at Vienna University where we go into details to talk about the future of scientific drilling, talk about are there new fields which were not included in the science plan we have from IODP, how cooperation with other programs should be, relationship to industry, what new technologies are needed, but also we will talk about the general structure, the management structure of the program, whether it should be as it is or whether it should change, and so there are a lot of things to be done, and we really hope that this fantastic program will continue beyond 2013. Thank you very much.
Before we open the floor, I would like to ask one question to both of you. What do you see as biggest challenge for the future IODP program beyond 2013? I think there are quite a lot, but what is the major challenge for you? Money, science, whatever. Katrin?
I think money is definitely one. But the funding agencies which presently participate in IODP have already started talking about the future, so they are interested in continuing. The problem is that the tools we need are becoming more and more expensive, and money will be an issue. But of course, because money will be an issue, and because we have themes in common, we feel that it's really important to cooperate with industry in the next phase, and also to address maybe questions which are more of societal relevance that we have been doing in the past. We have been really doing basic science, and maybe in the future we need to have more societal relevance to the science we achieve.
And Rüdiger, for you, what do you think?
Well, Katrin mentioned the money, of course. This is the big question. But if I only think about science, then and I would like to come back first to the high latitudes, which are, and that's the point, really unknown, but these are key areas for driving the climate system. Sea ice cover, albedo, and it has a strong influence of the global circulation and with this global climate. And a lot of things are really unknown, and to understand the climate system and also to model the climate system, that means to use models to say something about the future climate, you have to include the high latitudes. And for this, of course, we need new technologies, and there is this aurora borealis, which is extremely expensive. But of course, this is, if I do not think about money, this is the right way. And of course, maybe it's a dream, but hopefully it will become reality.
So IODP has to do something with pure discovery in part, but we should open the floor and ask you whether you have certain questions to the scientist. Holger.
Do you have a plan B just in case aurora borealis won't be realized?
How? Sorry?
Whether you have a plan B.
Just in case aurora borealis won't be realized due to fund.
But we have demonstrated that we can, with the technology we have, we can drill in the Arctic. Of course, it's more complicated to organize cruises, and it will be much easier to have a dedicated ship. But we can do it even without that ship. So
you won't have ASEX 2, 3?
We could, but...
Well, there are already proposals in the system to have something like ASEX2. But, of course, the optimum would be with something like aurora borealis. And if we are thinking about 1 or 2 or 3 expeditions within the 2 decades, then, of course, Plan B, that means something like ASEX, would be maybe better because it's less expensive. But we are thinking not about 1, 2, 3 expeditions, but about, let's say, 20 plus expeditions. And for this, as a whole, I think, Aurora is not much cheaper. You know, the ASEX expedition, as I understand, was 15 million or so, something like this, for one expedition. Yeah? And of course, there are also other possibilities that we try to put some drill rack on existing ships or something like this, but this is not the optimum. Yeah? No. There are some ideas, but I think we should not talk too much about these ideas. First, we really should go together to get the Aurora before I become retired. That was a personal comment.
Okay, any more questions? Bitte.
Why do you have so few data from the high latitudes?
Well, it's just the technical problem. There are not many ships which can go into the Arctic, let's say in general, more general, into the ice-covered region. And for example, JOIDES Resolution and the CHIQ, they are nice drilling ships, but they are not ice strengthened, so they cannot go into ice-covered regions. And for this, you need an icebreaker with a drill rack on top. And this is a point, Of course, the oil companies might have even bigger ships, but they are even more expensive, and they need their ships for their own drillings.
And this Borealis will be the first ship,
This will be the
first icebreaker which can drill?
for scientific drilling, yes. So the oil companies, they might have ships like the Canadians for sure. They have some the oil companies and Statoil and so, but this would be even much more expensive. For example, if you would hire some of these big icebreakers from the industry.
But also to drill in any place, you need to have what we call site survey data. You need to prepare the ground to know exactly what your target is and so on. And again, acquiring this site survey data in the Arctic is difficult because of the ice and the technology. So there are less data to prepare drilling cruises in the Arctic than there are elsewhere. And that's also a problem.
Again, there are only, I would say, for the scientific research, there might be 3-4 ships which can go into the ice, do site survey data, and take short sediment course of 5 to 50 meters in length or so. But that's it. And with this, you only get the uppermost, let's say, climate history, and you cannot go into, cannot drill into hard rocks that meet basaltic material, and so we have from the Arctic, we have about 700 to 800 short sediment cores. But that's it. But with this, you cannot answer the key questions.
What time is this 10, 15 meters in maybe in years or something?
This is, it's mainly the last 800, or let's say the last 1 million. It's the maximum. From these 700 cores, and there are three cores from 700, taken just by accident in the 60s. There they got old sediments, 50, 60 million years old sediments. There's the tectonic evolution behind that. These old sediments are there on top and at the surface, and you could take them. There are 3 meter long, just piece. That's the only thing we have from the old Arctic.
But we should add that we have the ASEX course from the Arctic coring expedition in 2004, which I think was 460 meters, 465 meters. So that adds quite a lot, and you can see the relationship between the other course and the IODP and ECORD course, how much you get. But Holger, you had a question.
Did I get you right that you are planning for 20 expeditions into the Arctic for the next decade of...
Now we had, no, that's maybe, this is my personal, you know, in November, last November, we had a workshop in Bremerhaven, and all people interested in the Arctic and drilling were there, and it's a program, let's say, really for 20 years, and you will not have every year an expedition. This was, when I say 20, if we at the very end, if we would have 10 to 15 or so. And this is the point, if we get a ship like Aurora Borealis, it doesn't mean that we will have the ship and this will drill throughout the year. In any case, drilling in the Arctic, even with Aurora Borealis, this will be during the summer months. That means maybe one expedition, and then the ship will be used for other purposes. But I'm pretty sure that, of course, it depends on the scientific community. They must submit proposals and so on and so on. After our meeting, our plan was April 1st was the last deadline for IODP, that 10 plus proposals will be submitted. Now, we got 7, but this is nevertheless. So we have 7 in the system, and but that's the first step. And the point is that not too many people are submitting further proposals, is that IODP will end in 2013, and beyond that it's open. So write a proposal, do all the site survey, and so this is time consuming and money consuming. And so if you do not know what will happen after 2013.
We will have a media conference tomorrow at 2 p.m. about the ongoing and planned IODP expeditions with some other experts. But Katrin, you would like to add something?
I wanted to say that obviously the Arctic is a hot topic for the future, but it's not the only topic that we would like to address with the drilling program. The deep biosphere, for instance, is something that we don't really understand, and there are lots of things to do still to be able to get good samples and understand what these bugs are doing at such depth in the sediment. But also to understand how the Earth system functions. One aim of the drilling program has always been to drill through the transition between what we call the ocean crust and what we call the mantle, the moho. And the moho is located at 6 to 7 kilometers beneath the sea floor. And this is something we started during IODP, and we have already drilled through the transition between the upper crust and the lower crust. But we have still 3 to 4 kilometers to go to understand what this moho is, which is really important to understand the dynamics of the Earth. And with the current technology we have, we are not able to do that because the CHIQ has currently limitation for the water depth where it can drill. So hopefully the Japanese are planning to develop better capabilities for the CHIQ, and in post-2013 we will be able to drill through the moho and unravel what is there and understand what the transition between the crust and the mantle is.
Okay. Rüdiger?
At least I would like to add one comment, of course, and I have to apologize that I only talked about the Arctic, because this is my own main interest, of course, also for the people interested in the paleo-environment and climate change, and so there are other key topics, for example, in the carbonate, shallow water or shallow water carbonates, coral reefs, and so on. You get highest resolution climate records, so that you can look for seasonal changes and so on and so on. So there are a lot of other things. And also the future, I think, is the combination, that means a project of IODP and ICDP, the Continental Drilling Project, that you can drill profiles from the deep water, shallow water shelf and continue on the continent. And so this is also one important future point, this cooperation with other programs and drilling programs. I would say for sure, and if you look at the, I have some more figures I will show on Thursday. If you go into the old, or not the old, the existing science plan from IODP, and not on every page, but almost, the term Arctic Ocean is mentioned. And up to now we have one drilling. And if we are in a lucky situation, we might get another one. At the very end of IODP. It could be, but it's totally open. So there are two, and then there are so many questions, I will not repeat them and then go into detail. You should come on Thursday or stay for Friday and Saturday.
Okay, more questions.
You talked a bit briefly about some of the technical issues. Can you explain how the Aurora will help?
Well, I'm not the specialist for these technical things, but the Aurora, this will be really a new, according to the engineers, a totally new thing. This is it's big. It's 200 meters or so and 50 meters in width, and it has a moon pool in the central part, 2 moon pools, and the big. Other moon is a hole in the ship that you can put the drill string through the middle part of the ship, and without that the ship will not sink. So
that's very important. I think
that's important. And this even will have 2 moon pools that you can do the drilling, and on the other hand you also can put some vehicles, sediment traps or whatever, everything into the water, even if you have a strong ice cover. This cannot be done now, and it's very, very powerful at the moment. Or if you think about A6, the first drilling, you needed this Russian atomic or nuclear icebreaker to crash the ice and so you need 3 ships. And with the Aurora, it might be that you can do everything with 1 ship. It can stay on the location.
Yeah,
position.
the
point.
major
That's the point.
breakthrough
That's
in
the point.
technology would be that the ship would be able to stay on station without the support of any other icebreaker. So that would be the major technological breakthrough.
And when will it be decided whether the ship comes or not?
Well, I will. This is at the moment there is this program funded by EU. That's for another 3-4 years, where technical things will be discussed, how the ship should look like, and also it would be the main part of the work of this group. Talk to the different European nations that the funding is coming, and it is not just building the ships. The point is you need 50-60 million or so per year to run the ship. That's even more difficult to get the money.
Okay, Bonnie?
You're interested in the Aurora Voice. I think there is a talk of, they will present the technical aspects of Aurora Borealis here in the session, but I don't have the schedule now. So you have to look in the program.
Which session?
No session, sorry, a talk. There will be a talk or a poster about Aurora Borealis, but I haven't.
Oh, yeah, you are talking about our session. Yes, there will be not a talk, but there will be at least a poster, and the presentation will be on this workshop we have on Friday afternoon and Saturday at the university. There will be a separate working group talking about new technologies needed for the new IODP type program post 2013.
Okay. Any questions or any comments from your side, Katrin and Rüdiger? That's it?
You had a
Oh,
question.
another one, okay.
I'm slightly confused why Canada is in the European.
Pardon?
I don't understand why Canada is in the European.
Oh, because we like each other. No, it's because to become a member of IODP, you need to contribute what we call a participation unit, which is quite high. And Canada couldn't do that, so they came to us and asked if they could join the consortium, and of course they were very most welcome.
Yes, okay. So I would like to thank you for having attended this press conference, and Katrin and Rüdiger, of course, too. I would like to point out that we have some material here for you, a kind of field book, which I think is very nice to have, especially for journalists. It tells the story and history of scientific ocean drilling, but furthermore, you have some empty pages in the end to make your notes, so to say, use it as a field book. And I would also like to invite you to come to our IODP booth, which is number 54 and 55, and to meet some other people of the outreach team, namely Alan Stevenson, who is here, Isa Kagaya, and also Bonnie Wolf-Böhnisch, who's sitting there. So if you need some more information, we have some other informational material here, Scientific Drilling, a journal, which is being published within IODP. So there's a lot of material and a lot more to say tomorrow afternoon at 2 p.m. about ongoing and planned expeditions. So thank you very much for attending this media conference. Thanks.